Hi everyone. Let's go ahead and get started. We got a lot to talk about today. First off, quick announcement. I've got office hours mostly figured out, so they're posted on the website. These may still end up changing a little bit as we fine-tune the schedule, but I think for the most part, these will be good to go. You'll notice that the location still has not been worked out for some of these office hours. I'm hoping to have that resolved very soon. And I'll update this once I get a room nailed down for those office hours. But these should be starting this week. Our first homework assignment's out today. I want you to be able to have resources to go talk to about this homework assignment. So these office hours should be good to go starting today, starting this week. My office hours are always on Wednesdays. So tomorrow you can stop by and see me basically whenever you want on Wednesdays, but we've got lots and lots and lots of office hours, including on weekends. We even have some hours on Sundays, so be sure to use those to your advantage. And I'll let you know if these get changed or updated. Yeah, so the big topic today is the homework assignment. Homework 1 has been posted to the course website. It's going to deal with what we were talking about in class on Thursday of last week, which is the heap files, and the heap pages. So what I want to do today is spend some time, first of all, going through the setup of this homework assignment. There's a little bit of work that you all need to do to get ready to work on this assignment. Then I'll do a brief overview of the assignment itself. I'll show you some of the code that's part of the assignment. And then I'm going to put you to work. At the end of class today, I'm going to have you do some work, and you'll be able to earn some credit on this homework assignment right now in class today. Before we hop in, any questions about logistics, office hours, other scheduling stuff? Yeah, in the back. If you didn't bring your laptop, don't worry. You'll be able to submit the work that we're doing in class today by tomorrow, basically. Yeah. If you have so again, as a reminder, you can work on a homework assignment with one other person. So maybe that one other person is here and has their laptop. You can just piggyback off of them for today. If you didn't bring a laptop, don't worry about it. It'll be handy if you do have it, but not a deal breaker. Any other questions before we hop into the homework assignment? Any other questions? Okay, so the way this homework assignment works, the way the setup works is I have a repository. Let me zoom in. I'm not going to read all this stuff to you. You guys can read this on your own time when you get around to it. But I am going to walk you through this process in class. If you have your laptop, you're welcome to follow along with me. I noticed some of you have actually already done this, which is great. I've made a repository that contains the starter code for this assignment and all of the future assignments as well. So what you need to do is go out and grab your own copy of that repository. But the instructions are very specific. I want you to do this in a very specific way. So first off, if you don't already have a Bitbucket account, that's step 1. I would recommend using your WashU email address when you register for that account. It makes it easier for me to know who you are, which is important because I want to give you a grade. So it's important for me to know who you are. So please use your WashU account when you register for Bitbucket. Once you have that, you can click this link to go to the repository page for the assignment. CSE530 Spring 2019. This is the right place. Okay. Actually, let me check something here real quick. Make sure that I did something. Oh, I did. Perfect. Great. I'm going to give you an overview of this code in just a few moments, but what you need to know right now is you need to create your own copy of this code so you can complete the assignment. It's called a fork using Git terminology. So the way to do that is one of these buttons over here. Which one is it? Branches. Nope. Nope. I swear every time I come to this website, they move things around. It's got to be around here somewhere. Whoops. Oh, you hit the plus. Thank you. Hit the plus, and then down here at the bottom, It's an option to fork this repository. Okay? Once you fork the repository, there's a few options that I want you to specify. Let me zoom in. For the repository name, I'd really like it if you would put your last name and your partner's last name, if you have one, on the name of this repository. Again, it'll just make it easier for me to figure out who this work belongs to. Yeah, in the back.
Wait, I'm sorry. Can you show me how you got there one more time?
Yep, for sure. I'll back up. So I'm on this page. Where did the button go? Let me refresh. Okay. I'm on this page. I click the plus. And then down at the bottom it says fork this repository. That takes me to this window. I would like you to add your last name and your partner's last name on the end of the name of this repository. I also want you to check this box right here to make it a private repository. It's very important. I don't want your repository to be publicly searchable. Basically, I don't want people using your homework assignment as their homework assignment, right? So protect yourself. Make your repository private. Yes? No, actually, you just need one repository per group. One repository per group. So only one person has to do this if you're working with a partner. Okay? I don't think we need any of these advanced options. As long as you add your name and mark it as a private repository, I'm going to be happy. So don't worry about any of this other stuff. I'm not going to do this because I don't need to, but you guys should then click the fork repository button, and that'll make your own copy. You now have your own copy that you can work on. This is the part where my phone blows up as you all fork the repository. Yeah, let me just turn this on mute so I don't go crazy. Should have thought about that before class. So there's a couple other things that you need to do before you're set up. You should have a screen that now looks similar to this one, except it's got your name on it, right, and your partner's name. So you need to do a couple more things before you should get started. Why does it keep disappearing that menu on me? Over here on the left, you see the little cog for the settings? We're going to go to settings next. There's an option in the settings for user and group access. It's the second one on the list. You should see your account listed there under user and group access. If you have a partner, you can type their username or their email address into this box to add them to the repository as well, so that you can both have access to that code. If you have a partner, you need to add one more person to your repository. Me. You got to add me so that I can see your work and grade your work. So to find me, you want to type in my email address. Is it my Woosel? I'm pretty sure it is. Or is it my Gmail? And make sure you give me admin access. Yeah. Make sure you type in my email address and give me admin access to your repository so that I can access your work and grade your assignments. Any questions? Be happy to answer questions. These instructions are all on the Homework 1 write-up, by the way, so if you don't have your computer or you got stuck, you need to give this a try when you get home. All the instructions are there. Yeah? dshook@woosel.edu, yes. Bitbucket is like GitHub. It's a host for Git repositories. So Git is a version control system. It allows you to make changes to your code in a coordinated way so that If you're working on something with a large group of people, you don't run into the situation where one person makes a change, another person makes a change and erases the change that was just made. It also keeps track of every single version of the code that you've ever made in your life. So if you want to go back to a prior version, it's very easy to do that. You can go back and look at the history of the entire project from when it was created until present day and access your code that way. It's a very commonly used tool. Lots of classes on campus use this, including 131, 132. It's a little bit different in those courses compared to this one. But any other questions? Any other questions? So then once you've added me and maybe your partner, if you have a partner, to this, you're ready to open up the code. I am going to use Eclipse just because that's what I feel like most people on campus are using, is Eclipse to do their programming. So hopefully you have Eclipse installed. If not, now is a great time to grab it. I already have Eclipse open. So let me show you how to get your code in here once you've got everything set up. I'm going to go back to the home page of the repository where I see all the files. There's a button up here called Clone. If you click that button, it gives you, we just need this address here. We just need that address. So go ahead and copy that. And now we just need to load it up into Eclipse. And the way we're going to do that is, once you have Eclipse open, you can right-click and select Import. And there's an option. I'm sorry, this text is small. I can't make this text larger. I can make some text larger, but I can't make this text larger. That option that I have selected says Projects from Git. Projects from Git. So select that option. You'll paste in the address that you copied from the website. I'm sorry. On this screen, we want the second option, Clone URI. And now, paste in the address that you got from the website. You need to log in. So this is your Bitbucket login, not your WashU login. Your Bitbucket login. And just keep clicking Next. It'll pull down the code from the website. You want to make sure Import Existing Eclipse Projects is selected on this window. And then you can hit Finish. And you should now be able to see the Homework 1 code in Eclipse. Are there any questions about that? I know I went through that a little quick. I would expect a large number of you have already done similar things to this in prior courses. I know some of you did not do undergrad here, so maybe this is new to you. I understand that. If you have questions about this, this would be a great thing to come see me in office hours about. I can get you up and running in a few minutes. If you want to come in and talk to me tomorrow. Yes? Existing Eclipse project is what you want, for sure. If you don't get it right now, that's okay. It's all right. Don't worry about it. You got lots of time. As I mentioned, all of the instructions that I just went through are on the website. So if you go back to the course website, all of the instructions are there. Under the setup piece, all the instructions are there. So take a look at it tonight if you need to. Come talk to me in office hours tomorrow if you get stuck, if you need help getting this set up. Be happy to go through it with you. Any questions on this right now before I move on to taking a look at the assignment itself? Any questions? Okay, let's talk about the assignment. This assignment has a few parts to it. And the write-up, which I highly encourage you to read before you start working, actually walks you through almost step by step exactly what you need to do to complete this assignment. So we're going to start with tuples. What's a tuple again? We talked about this Thursday. Tuple, how does a tuple match up with our database? A tuple represents, I think, did I hear somebody say it? A row, a record in a table. So a tuple is representing a row in a table. So the first thing we need to do is decide how these tuple objects are going to behave. They're pretty straightforward. It's basically a container of data. So I can pull up the tuple code. Let me make this font a little bigger while I'm at it because it looks a little small right now. If I can, preferences, font. Let's bump that up. Oh, okay. Wow. That's huge now. That's okay. That's good. All right, what am I looking at? I'm looking at the Tuple class. So tuple consists of, what's contained in a tuple? It represents a row. So what's a row contain? It contains data in the form of columns. So every tuple is going to have a set number of columns associated with it. So you need to decide how you're going to store those columns in this tuple, right? I would choose a very simple structure. It doesn't need to be complicated in terms of how you're going to store those items. We also actually need to store not just the data itself, but also information about that data. So what's the name of the column? And what's the type? What's the data type of this particular piece of information as well? And we have a second class to help us out with that called a Tuple Descriptor. You can see here I've already kind of set you up with some helper code on this one. We've got an array of types. And we've got an array of strings for fields. So this is going to be the names, the column names. This is going to be the data types. So if I look at element 0 of this array, that'll give me the name of column 0. And if I look at element 0 of this array, that'll give me the data type of column 0. Right? Let's talk about types for a second. We're going to restrict ourselves to a very small subset of types for the purposes of this assignment. We might add some more later. But for this assignment, we've got two data types. We've got integers and we've got strings. That's it. We're not going to worry about other data types for now. We're just going to do integers and strings. The data type is very important though. Understand again, we're using fixed length records. We talked about this on Thursday. So once I decide on the setup of a record, that's it. All records have the same size. So we've got ints and we've got strings, and the format for strings is worth talking about in a little bit more detail. The integer representation is nothing special. It's 4 bytes. That's how Java does ints. It's 4 bytes. So we're going to just follow Java's lead in terms of how to represent integers and just do 4-byte integers. Strings are a little tricky. We talked about this last week, right? We want to keep things fixed in size, but strings can vary in length. So we're going to use a data type more closely related to the character, not a varchar, but a char data type in SQL. And we're going to go one step farther than that. We're going to put an upper bound on the length that strings can be. So we cannot have a string in our system that's larger than 128 characters. That is our cap. That is our bound. But a lot of strings are shorter than that, right? Not all strings are going to be 128 characters. So we need to have a way of knowing, all right, how big is this actual string? The way we're going to do that is with a byte out in front that tells us the number of characters in a string. So a string, if I come across a string in this database, the first byte is meant to be the length. Byte number 1 is going to be the length. There are 5 characters. Then after that comes the character data. And then after that, because I want this to be fixed length tuples, what comes after this? Padding. There has to be some kind of padding. We're going to do spaces, right? You won't actually see the spaces. They're literal spaces, right? How many of them? A lot. All of my strings are going to be the same size. They're fixed length strings. So how big is this string going to be? How big are any strings going to be? Close. 128 is very close. I said that a string can at most be 128 long, but we got this guy. So the answer is 129. 128 bytes of text, of character data, plus 1 byte for the length that appears up front. All strings are 129 bytes long. All of them. You may be thinking to yourself, that is horribly inefficient. You are correct. That is inefficient when it comes to space. Very, very, very inefficient when it comes to space. We're making some trade-offs here for the purposes of this assignment. Some important trade-offs. Are there any questions about the format of the string? Yes?
If you're concatenating the int string, doesn't that turn it into a string?
But be careful. So yes, in Java, that is true. If you concatenate an int and a string, it becomes a string. But we're creating our own format right now. This is our database. We're creating these data types from scratch, basically. We get to decide what a data type looks like and how it behaves in our system. If I'm looking at this data in a file, I don't even see a string. This is a byte. This is a byte. This is a byte. This is a byte. It's all just a series of bytes. And then it is up to us as programmers, as you complete this assignment, to read in those bytes properly and turn it into something more usable, like a proper string object, right? That's really what this assignment is. Taking bytes from a file on disk, understanding the format that those bytes are going to take, and reading in the data. And then the opposite direction too. Taking some information, turning it into the appropriate bytes, and adding it to disk. So the tuple descriptor, the tuple descriptor, right, has the type information, the field information. It does some other things as well for us. Number of fields. I can get the names. So give me an index and I'll tell you what the name is. Go the opposite direction. Get the types. And then here is an interesting one, or a useful one, actually. Get the size. So tell me how big this tuple is in bytes. It's actually pretty straightforward. I just said, right, ints are 4 bytes. Strings are 129 bytes. So go through all the columns, figure out what types they are, and add it up. And return the size. Equals and hash code, and that's going to about do it. So we have this tuple descriptor. I think it goes without saying that there's going to have to be, well, here it is in the constructor, as a matter of fact. This class is going to need that tuple descriptor, right? So what is this class actually storing? If the descriptor is storing the type and the column names, this class then is storing the data, the actual data. What string do you want? What ints do you actually want? That's what this class is doing for us. You'll notice some other interesting information down here which will be useful once we get to the heap pages and heap files, which is coming up next, such as they know what page they're stored on sometimes, right? Sometimes tuples will know what page they came from. If I read a tuple from disk, I actually know what page that tuple came from, and I can mark it as having come from this particular page, which is going to make our life easier if we change that tuple or need to modify that information. I know exactly where to go to look for it. So that's what the PID and the ID are. Those will make a lot more sense when we talk about the heap pages and heap files, which I think is... Actually, we're going to talk about the catalog first, and then we'll talk about heap files and heap pages. Any questions about tuples before I move on to the next one? All right, let's talk about, let me make sure I didn't skip anything. All right, the catalog. The catalog is an example of something that is stored in a database that's not actual data. It's information about information. So what do we call that? Metadata. The catalog is metadata. We're already tracking metadata in our database. We have to. The catalog basically is keeping track of what tables exist in the database. What tables are there in the database? And it's going to keep some very basic information about those tables. You can see right here, it's going to track the name of the tables, obviously, the location of the file. So all of these tables are stored in a file on disk. One file per table, one heap file per table. So where is that file stored? Where can I find that file with the data? And then if it has a primary key, I want to know what the primary key is, the primary key column is. The catalog class actually has a lot of code provided to you already. Down here at the bottom, load schema is a method that's already been completed. You don't need to touch this. That can read in a table from file and create it on this system. I'll actually show you how this works when we get to testing in just a little bit. But all of the other methods that you see in the catalog deal with the information I was just talking about. Tell me where the file is for a particular table. Tell me what the primary key is for a particular table. You're going to need that information as you complete the rest of the assignment. So that's part number 2. The last part number 3 is actually probably the most difficult, the one that's going to require the most of your time. I think you can get the tuples and the tuple descriptors done very quickly. I think you can get the catalog done pretty quickly as well. The heap files and the heap pages are what's going to take a little bit of time. So let's take a look at those. I meant to start with heap file, sorry. All right, right up at the top of our heap file, there you see our defined size for a heap page. All heap pages are going to have the same size, right? In this case, we've specified that size as 4 kilobytes. 4 kilobytes per page. So if you ever need to refer to page size as part of your computation, you can just use that variable there. The heap file, remember, its job is to manage the pages. The heap file's job is to manage the pages. It doesn't really care about the tuples or the records. That's not its concern. Its concern is to manage the pages. So what we're going to see down here are read page. I give you the index of a page. You have to find where that page lives on disk and give it back to me. Give me that heap page back. Right? And then the opposite operation is down here as well. Write page. I've made some changes, I've added some data, right? I've made some updates. I now need to take that information and save it back to disk. So that's going to be write page. I give you a heap page, and you have to write it to disk. There is a method here called add tuple. This is what we actually went through at the end of class on Thursday. What's the add tuple method do? You can kind of see the description a little bit. What's it do? We went through pseudocode for this on Thursday. Could somebody describe it real quick? Yeah. Bingo. Yeah. Finds a page that's got an empty slot for this tuple and then puts the tuple on that page. If there aren't any empty slots, then we have to make a new blank page and then we add it to that one, right? Okay? Deleting is on here as well. Here's a big hint for deletion. A big hint for deletion. The tuple, again, remember, the tuple knows what page it lives on, right? Ask the tuple, what page are you on? Get that page. Ask the tuple, what position are you in? Go to that position and update it, right? And then last but certainly not least, down here at the bottom, a couple methods to get all of the tuples from a file. This is more for testing purposes than anything else, really, just to make sure that you got the right information into the file, and then tell me the number of pages that exist in the file. And so last but certainly not least is the heap page itself, which you can see also has some work done for you. Actually, pay attention to the important pieces of the heap page. We've got a byte array for the header, and then I've got an array of tuples as part of the page, right? I have a certain number of slots, so how many positions are there in this heap file? That's something that you actually will need to compute. Get number of slots. This is another problem that we did in class on Thursday. We computed the math for this on Thursday. Get number of slots. It also tells you, well, that same math actually will also tell you how big your header should be. You have to do a little bit more arithmetic to get there. But let's talk about that for a second. What's the role of the header again? What's the header do? Yeah, in the back. Yeah, so using the terminology from the write-up, you're exactly right, but using the terminology from the write-up, it tells you whether a slot is occupied or not. The page has a certain number of slots, right? A certain number of positions where tuples can go, and the header tells you whether that slot is occupied, it has information in it, or not. So the header is just a series of bits, ones and zeros, where a 1 indicates that that slot is occupied and a 0 indicates that that slot is not occupied. So the header size is based on the number of slots that you have, but we don't want to use partial bytes here. So for example, if I only had 3 slots, my header size would be 1 byte because I don't want to use a partial byte. So you have to do a little bit more arithmetic to get that value. Slot occupied. So is there something here or not? Again, take a look at the header. Examine the bit. Is that bit set or not? That'll tell you whether it's occupied. This is going to take some low-level programming to work out. You're going to have to do some bit manipulation to work out some of these methods. So things like bit shifting, right? Things like logical ands and ors, or I'm sorry, bitwise ands and ors are going to be necessary to solve these methods. We're very low level here. We're dealing with binary data at the byte level. So these are all set slot occupied is going to manipulate the header, and then add tuple, right? I should only get here if I have an open position, because the heap file is already going to be checking. So by the time I add a tuple to the page, I should have an open spot. So it's just a matter of finding where that spot is and adding the tuple in the appropriate location. Deleting a tuple, same story, but in reverse. And then you don't need to worry about this method. It's already finished for you. Yeah, I think these are all done, actually. And that's the entire assignment. We've gone through all of the files. I know I went through some of it faster than others. Again, I would highly encourage you to read the write-up. There's a lot of important information about this write-up, about this assignment on this write-up. Are there any questions that I can answer right now before I shift gears to another important topic? All right, I want to show you some examples, actually, of this database in action. I think it will help you to see this code, or I mean, obviously this code is blank, right? So I can't show you a fully working example, but I can show you parts that are working and give you an idea of how this database is supposed to work. I gave you some unit tests. So if I look at the test package down here, you can see several test files. We can start with the tuple test since that was what we started talking about. I gave you some unit tests here. These are not comprehensive. There's a lot more to be tested than what's given to you in these unit tests. These are meant as a starting point for you. But I wanted to take a look at a couple of these tests real quick for a couple of reasons. One is to show you how these tests work, and also, two, to get a better idea of what the assignment is capable of doing. You can see that I'm going to create a new tuple description with ints and strings. So I'm going to create a table that's got one integer column and one string column. And these are the names of my columns. Not very great names, but whatever. I create some random information to be added to those columns. So it's literally going to create a random number and a random string, right, to be put in to this tuple. And all I'm doing here is adding these to the tuple and then asking for them back and making sure that they are equivalent. I'm making a tuple, I'm putting information into the tuple, I'm then saying give me that information back, and all I'm making sure is that the information I get back is the same as the information that I put in. That's what these assert true statements do down here at the bottom. That's the test. Seems like a pretty simple test. It's meant to be a simple test. Let's take a look at something a little bit more complicated, like a heap file test. So this test is set up a little bit differently. You see here that I've got an annotation before this method. That's called an annotation when you see the @ sign in a piece of code like that. That's an annotation. At before means that this code is going to run before any of the unit tests are run. So this is setup code. If I want to create some objects that I can use to help me perform my tests, this is how I can accomplish it. And this setup code is actually loading a table into the database based on a file that was given to you. So down here in this test files folder, you can see 3 files here. Let's take a look at these real quick. If I open test.txt, I don't know why that text is so small, but it's just a very small piece of information. This is the name of the table. This is the name of the first column followed by the data type. This is the name of the second column followed by the data type. So this is a schema, right, specifying that I have a table called test with 2 columns, 1 integer column and 1 string column. So far, so good. The actual data itself is in test.dat, but it's in binary. So if I open this file, I'm not going to be able to expect to read that information. It's in binary. So I have to think about it a little bit more carefully. Let me see if I can make this bigger. No? Is there no way to make the text bigger? Can I zoom in? No? Well, shoot. Okay. I'll do the best that I can. This is a hex editor. What we're looking at here is a hex editor. I really wish I could make this text larger. No, that's not what I want. I'm sorry, I guess I can't make this larger. This is a hex editor that I'm using to examine this information in binary. So the first bytes that I expect to see here are going to be what? What's the first set of bytes that I expect to see in these files? A header. I expect to see a header, right? And the very first byte that I see in the header is 0, 1, which looks like this in binary. Eight bits, right? 0, 1. This is the header. There's a 1 here. What does that tell us? A 1 in the header means that position is occupied. It might seem a little backwards to you, though, right? This is position number 1. So I'm reading this bit first. This is actually the first bit of the header. So you have to be a little bit careful about that. I read a byte from right to left. So this is position number 0. This is position number 1, 2, 3, 4, 5, 6, 7. If I had another, right? If I had another byte of my header here, position 8, 9, 10, 11, 12, so on, so on. So be careful how you read in those header bytes. This header is telling us that there is one tuple in this file. And remember, our tuple takes the format of an int and a string. Question in the back. So Java is always going to use the same endianness for things. And remember, we're designing the system from scratch. So if we wanted to flip it so that it went the other way, we could. We absolutely could. However, I think it's in our best interest to try and go with the flow in terms of what Java does when reading and writing files, which is why it's set up that way. Yes?
I'm still confused on how it works out.
Okay.
Okay, so I understand like each bit represents like whether something has got a position in it or not.
Yep.
I don't get inversion.
The inversion? You mean like why this is here and not here?
Yeah, I mean now looking at this, I have no idea what position that is. I mean, like, is it 1? Is it like we count the zeros and it's like?
Well, this is hex. Remember, this is in hexadecimal. So this is what that first byte looks like. Those two numbers, that 0, 1 is actually 1 byte. 4 zeros and then 3 zeros and a 1.
Concerning the size of the header, I guess.
So that's the.
Knowing this, does this header only have like 8 positions?
Well, that's the question. That's actually a very important question. How big is the header? That's something that we should be able to figure out, right? We know the math behind that. It's dependent on the number of slots. So how many slots are there? That depends on what? Not the number of pages. Yeah. The page size and the size of each tuple. So the page size is constant. 4 kilobytes, 4,096 bytes. That's constant. That will never change. The size of the tuple, in this case, is what? We actually know that information. Yeah. You got it. plus 4 bytes. Yeah, so 133 bytes. 133 bytes is the size of a tuple, right? But the math, we did this on Thursday. I'm not going to rehash the whole conversation. The math is not as straightforward as 4 kilobytes divided by 133 bytes. We have to take the header into account. So it's all computable. It's all arithmetic. We can compute how many positions there are in a file. We can then compute how many bytes there should be in the header. Yes?
But, well, I'm still confused on that part. Like, I guess it's kind of getting off the board right there. So, if, like, if this file, like, just for the sake of argument, did take up 2 hexadecimals, which is like 2 bytes in this, like, case right here. So, that first one, would it be on the second byte?
Yeah, so the very first position starts as soon as the header is over. So I have to know how many bytes are in the header to know where the first one starts. Now we can actually sort of infer a little bit about some of this information. We know that the data contained in this is an integer followed by a string. So if I look at this hex data, it's actually showing me, you can see I'm cheating a little bit. There's the word high right there. That's not a coincidence. The word high is our string. So that means this 2 is what? That's the length. That's the length of the string. So my string starts here, right? My string starts here and goes for 129 bytes. So there's a whole bunch of zeros after here. That's the padding. But we had an integer that comes before that. So 4 bytes in front of this, 3, 4. These 4 bytes, that's my first column. That's my integer. I can't do that arithmetic in my head. I think it's 530, actually, whatever that number is. And so that leaves us how many bytes for the header? 1, 2, 3, 4, 5 bytes for the header.
Yeah, but it's still almost the question I was really asking. I guess it's the same as what you're saying on that board right there. The first byte represents positions 0 through 7.
Yes.
The second byte represents positions 8 through 15.
Yes.
But each one is like flipped in order itself.
They're a little
So,
Indian.
So if you read left to right, you're actually going ascending, but each one within its own bias.
Yes.
Okay.
Yep. Was there another question in the back?
Are we using no bytes for padding or ASCII spaces?
Just all zeros. So that's null bytes, I guess. Yeah. Just all zeros. I know that this hex editor is not the best to see since the text is so small. Actually, though, for the purposes of this assignment and actually some of the ones that come after this, it might be in your best interest to go out and grab a hex editor so that you can examine these files and understand what's going on. That would allow you to do things like make some changes to the file and make sure that those changes appear appropriately in the data after it's done. I should be able to add a tuple to this and then see that tuple show up in this file and know exactly where it's supposed to show up in the file, right? The exact position where it should be within the file. So this table has one row in it. It's got an integer followed by a string. I know that the header is 5 bytes. That's not necessarily, so that does not necessarily mean there are 40 slots though, right? That last byte may not be using the whole thing. There are 40 or fewer slots on this page, which the arithmetic, I think, works out for that. You can do the math if you want to on paper, or, I mean, you'll be coding up the arithmetic in your homework assignment submission anyhow. Any questions before I go back to the unit tests code? Any questions about this? By the way, if you want to go find a hex editor, I'm on Windows. The hex editor that I use is called HXD. It's fine. Hex editors are not particularly complicated. It's the one that I use. Question? Yeah, what's up?
So I'm still a little confused. You have the header.
Yes.
And then you have the int.
Yes.
And then you have the characters for your string. And you said that 133 is the number of bytes
Yes.
How did you get 133 and not 132?
So a string is 129 bytes. An integer is 4 bytes.
So we said that the string was 129, not 128.
That's correct.
We have 1
For the length at the beginning. Yes.
So where does that get?
This is the length right.
5?
This is the length right here. It's a number 2. There are 2 characters in this string. Following this number 2 are 128 bytes that represent the character data of the string, but only 2 of them are non-zero because, again, I only have 2 characters in this particular string. So this string does not stop for 128 bytes, which is somewhere in here. Actually, probably bigger than that. 16 per row, so that would be 8 rows. 1, 2, 3, 4, 5, 6, 7, 8. The end of my string is technically right there. Yeah.
So what's all the bytes before that infinite? Is it all the header?
It's all the header, yeah. That's all the header. I only have 1 tuple, so there's 1 bit that is set. All of the rest are zeros, indicating that all of those positions are open. As I add more data to this heap page, I would expect these to start flipping over to be 1s.
The header is for the entire page.
For the entire page, yes. There's only 1 page right now. We only need 1 page because I've only got 1 record, right? But eventually, if I filled this page up, I would have to add a second page, which would start at byte number. You can actually scroll down and see that's 4 kilobytes right here. This is the end of 4 kilobytes. If I added a second page, it would show up here, and I would see another header followed by more records. I'm sorry?
So each tuple does not have like its own header, right?
Nope.
They're just stored right next to each other.
Yes, that is correct. Yes. That is correct. Yes.
Are we allowed to edit this file for testing? Should we create like our own DAT file?
That's a good question. So let me go back to the unit test real quick. The question was, can you edit this file for testing? Let me show you how I actually use this file. There's actually 2 copies of this file. Test.dat is the one that if I wanted to add stuff or do anything to it, that's what would happen, right? It would get added to that file. I gave you another copy, test.dat.back. It's a backup copy. Basically, the reason for that is I expect your code to not work the first time around. You're going to make some mistakes. So this is a fresh copy that gets loaded every time you run the tests. That's what this setup code does. It tries to copy this backup file into the original position, basically erasing anything that may have happened in the past, giving you a fresh copy. So in other words, you could change that file, but the backup's just going to erase it the next time around anyhow. If you wanted to set up your own tests with your own test data, you're certainly more than welcome to do that. In fact, that's what I'm hoping we're going to do here in just a little bit. But I just wanted to go through this test again real quick with you. Great question. So this setup question, as I just explained, is setting up this table that you can use, or that we are going to use, to test our code. And so then all of these tests, anything marked with @test, that's an actual unit test that's going to be run on your code. Anything that's marked @test is going to be executed using these objects. So there's a catalog object, there is a tuple description object, which based on the table that we just looked at, right? I expect that tuple descriptor to have an int and a string with those column names, right? And the heap file itself. So we test some simple getters. Make sure that the tuple description matches what I expect it to be. Make sure that there is one page in the file that you read in, right? There's only one tuple, so there should just be one page. Make sure that you can read page number 0 and that it's not empty, that it's not null. Make sure that you're actually reading something. We can be more specific than that, right? And that's what some of these other tests try to do. So here we're going to do a test where I write a new tuple to the file. The first thing I'm going to do is I'm going to create a tuple. That's what these lines of code do. I'm going to create a new tuple, and then I'm going to pass it to the heap file. Add this tuple. What should it do? It should say, it should look at that first page and should say, oh, there's lots of room on this page. Plenty of room for this tuple on this page. I'm going to add that tuple in to this page, and then how's my header going to look after this? After I add that tuple, what do you expect the header to be? Which bit's going to change? Yeah. In the back. This guy. It's now occupied. I expect this bit to now say that it's occupied, right? And so then it tries to read all of the tuples from the heap file and make sure that there are 2 of them now. This confuses people sometimes. Why 2? Because there was already one in there. I just added another one. So there's 2 now, right? There's 2 now. Test for deletion. Again, create a tuple. Try to delete it. If it gets deleted successfully, there was only one in there to start with. So if I delete the only tuple that was in there, I now have 0 left. 0 tuples. Right? Are there any questions about this? Because we got about 20 minutes left. I want to present you guys now with an opportunity here. There's a file called yourunittests.java. You can see that I actually provided you with the setup code. The same setup code, or it might be very slightly different, I'm not sure. The very same setup code that we just saw that loads up this test database. And what I would like for you all to do, or at least consider doing, is write some unit tests for this assignment. You might be thinking, well, that's insane. We haven't written any code for this thing yet, right? That's actually okay. It's a very common programming paradigm, test-driven development. I'm going to write the tests first, describe the behavior, how I expect things should work, right? And then I'll go back in and I'll actually make it work, make it do the things that I expect that it should be able to do. That's test-driven development. I want you guys to write some unit tests, and I'm going to give you credit for doing it. If you submit, what did I say, 2 unit tests to me by tomorrow at noon, I will give you 5 bonus points on this assignment. 5 bonus points on this assignment if you submit 2 unit tests to me by tomorrow at noon. I'm going to spend some time talking to you about it right now for the rest of the class today. Was there a question?
Yeah, does the assignment already say where we submit it to?
So to submit it, you just commit and push code in your repository back to the internet. Yeah. You just commit and push your code back, and then what's going to happen, I'm going to go through the submissions tomorrow. The due date is tomorrow at noon. If you submit your unit tests by tomorrow at noon, I'm going to grab them all tomorrow afternoon. I'm going to go through them, right? Give you credit, give you the bonus points for submitting them. But then I'm going to compile them all together and give them back to you. And that's what I'm going to use to grade your assignment. I'm going to use tests that you wrote to grade your assignment. And if I don't get enough tests, well, I'll just write it myself. But you guys would be missing out on some bonus points if you did that. So I want you to do it. I'll write it myself if I have to, but I don't think I should have to. I want you guys to write these tests. So how do we write a good unit test? Let's talk about that. How many of you feel confident in your unit test writing abilities right now? I see like 1.5 hands. That's about what I expected, right? That is about what I expected to see. Let's talk about it. A unit test. One unit test should be simple, very straightforward, and ideally should test one very small part of the program. Let me explain what I mean by that. Let me find a good example here. If I look at, well, let's just go back to the heap file test that I was just looking at, right? Heap file test. I've got a test write. All it does is test that you can successfully write a tuple to the file. That's it. It doesn't care about any of the other parts of the behavior of the program. It is testing one very narrow, specific, focused part of the program. Everything that it does, everything that this test does, is set up to test whether or not you can write one tuple to a file. The read test is the exact same thing in reverse, right? Remove test, rather. Can you delete one tuple from this file successfully? So what does a good test look like? There's some setup. I have to prepare some objects usually. I have to do the thing that I'm testing for. So it's called test remove. I'm testing, this is the method that I'm testing, delete tuple. That is the method that is being tested, right? So set up anything that you need to, run the method that you are trying to test, and then check the result. We do that with an assertion. Assert true, that's an assertion. If this statement is true, the test succeeded. We got the behavior that we wanted. If this test is false, then something went wrong. What went wrong? I don't know. But if we keep our tests small enough, if we keep them focused enough, it should be pretty straightforward for us to figure out where things went wrong. That's why it's important to keep your tests as narrow as possible. If I make this giant broad test that's testing 100 different things in my code and the test fails, I now have to figure out which of those 100 things did not work. And that's going to be difficult. We want our tests to be simple, straightforward, concise tests that test a very simple unit of execution, in this case, writing a tuple to a file. So there are plenty of methods in this code that have not been tested by the tests that I gave you. Lots and lots and lots of code that is not covered by unit tests currently. I want you to look at those methods and think about how you might actually test them. Let's do one example together as a group with the time that we got left. I'm going to go to Heap Page. And one of the things that we've already talked about quite a bit is this get number of slots, right? This get number of slots method. We did the math up on the board, right, and everything. How would I go about testing this? What would I have to do to test this method? What information would I need to test this method properly? Yes?
Size of the entire file.
So I know the size of the entire file already. Actually, I actually just need a heap page, right? I need the page itself, some kind of a heap page, right? The heap page ideally knows how big it is. It's hard-coded into the program. So I need a heap page. What else? What other information do I need to know in order to properly test get number of slots? The heap page, which knows how big it is, and also, yes? The header. Not quite. The size of the header? I'm using this to compute the size of the header. It's sort of a chicken and the egg problem, right? I need to know the number of slots to know how big the header is. So it's not the size of the header, yeah. Size of a tuple, which I get from tuple description. The tuple description knows how big it is, right? So if I want to test this method, what do I need? I need a heap page. I need a tuple description associated with that heap page, right? Which actually, I believe, is part of the constructor of a heap page. Actually, no, it's not. I'm sure it grabs the tuple description somewhere. Where does it grab? Oh, here it is. It grabs the tuple description from the catalog. Even better. Okay? So, if I wanted to test this method, there's a couple ways that I could go about doing it. We have a heap page already. If I look at this test file that I started you with, we have a heap page already, right? It's already here. It's already loaded up for you. It's called HP. It's pulled from that test.dat file that I was just looking at with you a few minutes ago. I already have a heap page. This test could actually be very simple, very straightforward. You know, how many slots do I expect to be on this heap page? I actually don't know the answer to that off the top of my head. I used to, but I don't. I know how to compute it. So what we might do is I might say assert true. This might be a very easy test. hp.get get num slots equals however many slots I expect to be on that heap page. I have to do the math. But I'm not going to do the math. Maybe one of you will do the math. Now, this is all fine and good. I would argue that this is actually not a great test because it's almost too specific. It's tailored towards this very specific example. So what I might like to see in a proper test that tests get num slots, if I wanted to make this a proper test, I would want to make another heap page with a different size tuple, right? So make another tuple description, make another heap page with a different size, call get num slots, and check that value. And I might do that a few times, right? So just this one example is not enough. Test further with other tuple sizes, right? That's what I would expect a good test for this method to look like. Notice, though, that I'm not going to test anything else in this method. In this particular test, I'm going to test get number of slots. That's it. I'm not going to test anything else. Yes?
The fact that it says get test for other tuple sizes kind of implies to me that you're going to want to call it multiple times within the same method.
Sure.
But I'm thinking, isn't that like kind of like the simplicity because now you're actually testing if it succeeded
So,
here, if it succeeded here, if it succeeded here.
Well, so each one of these assertions has is sort of a test within a test in a kind of way, and you can also, I believe, include a failure message. Size of this page should be X. I don't know what the size should be. Did I do that properly? Oh, it's mad because I don't know. I didn't put in a... Right? So... Oh, I got the parameters backwards. Okay, this is better. So this is an error message, right? If the test fails, this message gets displayed. So it indicates to the user of the test some information about what went wrong. And that can help you figure out too. You're correct in that I do want to keep things simple. I want to keep them focused. As long as my assertions are all testing the same method inside of the same test, I'm okay with that, right? I don't want to have necessarily 100 different assertions in there, but having multiple assertions in the same test is okay as long as all of the assertions that I'm making are testing the same thing, the same method. Great questions. Any other questions about this? So if you want to do the bonus credit, which I really highly recommend you do, if you want to get the bonus points for this, what should you do? I already gave you some tests. If I test a method, it's probably off limits already. I've already got a test for it, except there are some exceptions to that rule. For example, test right does a great job of testing if I write one tuple to the file, but what if I need to add another page? What if the page is full and I need to add another one? It does not test for that, which is actually very important. And I want there to be a test for that particular case. So there probably should be another unit test for adding a new page that would also use the write method. Add tuples until one page is full, then add one more after that. Make sure that you now have 2 pages worth of information instead of just one. Could be an example of how that test would work. So go out there, find methods that are not tested at all. Get number of slots did not have a test. I started one. It's not complete. I hope I don't get like 100 different get number of slots tests now. I don't need that many. I only need one, right? Go out there, take a look at some methods that have not been tested, and come up with a test. Once you have a test, put it in this file, and then you'll send these to me by noon tomorrow, and I'll get your tests. I'll combine them together into a set of tests and ship them back out to you hopefully by the end of the day tomorrow evening. Then you can use those to check your work as you proceed through the assignment. In the future, so I'm giving you bonus credit on this assignment because I realize that not many of you have done this before, and it's kind of a new thing for you. In the future, this is not going to be a bonus. This is going to be expected of you on future assignments. I'm going to expect you to write unit tests. It'll get better. We'll get better at it as time goes on. I know this is new. I know not a lot of you have seen this before. That's why I'm bringing it up. I think it's an important skill. I want you to get some practice doing it. What questions do you have? Anybody have any questions? Yes? Does it return a null pointer right now? It might, because the other methods aren't implemented yet. In fact, that's actually a very good point. When you write these tests, they're not going to work, right? Because you haven't done the assignment yet. That's okay. If you're don't wait to submit tests to me until they're actually working. No. That's going to take too long. The tests are meant to be able for you to run as you go through to make sure that things are working the way it's supposed to, right? So don't worry. These tests are not going to work. This test will not work right now. I guarantee that it will not work. I don't think any of these tests will work right now because the assignment is blank. As you complete the assignment, more and more of these tests should become functional. And hopefully by the time you're done, they should all be functional. As I said, I'm going to use this to grade the assignment, these tests to grade the assignment. And there is a rubric already posted at the bottom of the assignment page with how grading will be done. So once I get tests from you, I will assign point values to those tests so that when I run the unit tests, it'll just spit out the point totals as it goes along. Yes? Yes, 1 byte. What if the length of the string is more than 128?
No, more than 10 or 100. So the number is more than 10 or 100. This is still 1 byte.
So what's the largest number I can represent in a byte? 8 bits, 2 to the 8th power, 256. We could actually go up to 256 characters in our strings with 1 byte's worth of length, but I capped us at 128. It's just a byte. You're going to have to do a lot of low-level, byte-level, bit-level manipulation for this assignment. They won't all be like this, though. We'll work our way up, higher and higher up in the system as the semester goes on. What other questions do you have? All right. You guys should be set to go. Remember, office hours are starting this week. I'll be in my office all day tomorrow. If you're confused about what happened today, come talk to me. I'd love to chat with you about it.